All right, we are starting Chapter 2, Section 6, called Ratios and Proportions. I'm going to start the video out the same way I've been starting out all my other ones, just kind of walking you through what the screen looks like. So this is what it will look like when you click on any assignment, with the exception of two things. So first thing is you will see a due date here. I don't see that on the teacher preview for whatever reason, but you will see it on your screen. Attempts, you will see one of unlimited attempts, or whichever attempt you're on. This might not be your first time in here. Unlimited means I can come in here and try this assignment as many times as I would like. I need to submit it every time I come in. I'll talk about that in a minute. This particular assignment has 8 questions on it. They'll have anywhere from 1 to 10 questions. So just, be aware of that, the number of questions there. Grading policy is best score. So whichever attempt is your best one is the one you get to keep. And partial credit is enabled. So if I answer one of 8 questions, I get credit for the 1 question. So this is where we get into the submitting button. So please remember that you always want to finish or submit your work. So once I click the start button, this is the second thing that will be slightly different on your screen. Down in the bottom right corner, you should see Submit Assignment button. I don't see that on the teacher preview because I'm not actually going to submit this button or this assignment, but you should see it here. So as soon as you start this assignment, you need to click that button if you're done and you want to leave. So I'm not saying click it right now if you're working on it, but as soon as you're ready to leave, you need to click that button. So whether or not you've answered any questions, you've only answered one, or you've answered all of them, you're going to click Submit Assignment. Number 1, that shows us that you are in here working. It shows us what you've completed and at what percentage you've completed it. The other thing is that if you don't click the Submit Assignment button and you just leave the screen by closing it or going back to home, it's going to lock you out of every other assignment. You won't be able to do topics, quizzes, homeworks, or tests, other homework assignments. None of it will open until you come back to this assignment. So that's definitely kind of a bother if you do that. So make sure you click that Submit Assignment button. On the right side here, we have explanation, example, and message. You might also see calculator from time to time. So explanation will literally give you a solution to the problem we are looking at right now. So it's not going to give you the answer and then have you come type it in. You're going to lose that question attempt. So it will give you a red X here, and you'll have to submit the assignment and come back and try another one. And you can, go through and do all your other questions first and then come back and try this one if you want. But you can also click Example, and this will give you just a general example of this type of problem. So here we can see write a ratio as a fraction in simplest form with whole numbers in the numerator and the denominator. So that a ratio is a fraction, and we're comparing two numbers, 16 yards to 56 yards. So we can see that's happening here. 16 yards to 56 yards. We just have a fraction form now. And then we also have to simplify it. It's said in simplest form. So we need to make sure we simplify it all the way down. Otherwise, it's going to mark us wrong. It will not just let you do 16 over 56 like it has here. We have to go all the way down so that we are simplifying down to 2 and 7. If I want another example, I can click on example again. It'll give me a brand new one. And I can message my teacher from here as well, which it'll attach this question to the message. So now we know exactly where to come help you. Okay, let's go ahead and get started on this guy. So we have write the ratio as a fraction in simplest form with whole numbers in the numerator and denominator. So they do not want any decimals here. Okay. So if we have 24 years to 56 years, we're going to do just like they did on that example. 24 years to 56 years. So 2 is another way of comparing with a fraction. So that means that we need that fraction bar there. Years are going to cancel off year over year, and we're just going to compare the numbers now. So 24 over 56. Well, we want to simplify this as best we can. So we can think if you can identify the greatest common factor, that's definitely helpful. But you can also just say they're even. I can divide by 2. And you can do that multiple times. So in this case, I believe the greatest common factor will be 8, if I'm thinking of that correctly. They both divide by 8 here. So that's helpful. I could do 2s. I could do 4s. I just might have to do the division more than once to get all the way to the end. Because if I do divide by 2, well, that's not going to be done. I'm going to have to divide by 2 again. And that still won't be done. I'm going to have to divide both by 2 again. So if I know the greatest common factor, I can just divide once. So 24 divided by 8 is 3. And 56 divided by 8 is 7. So that was definitely the greatest common factor because 3 and 7 are both prime and they cannot divide into each other. So 3, 7. And if you notice, if they wanted years on here, it would have either already been here or it would have been a clickable button. So that's how I know they want us to cancel those out, since there's year on the top and year on the bottom. All right, next one. Charmaine made $247 for 13 hours of work. At the same rate, how much would she make for 9 hours of work? All right, so we can set up a little proportion here. So they're kind of jumping straight into proportions. So a ratio is just what we were just doing. It's just two numbers being compared in fraction form. So that was a ratio. When we have a proportion, that means we're going to have two ratios equal to each other. So we have a fraction equaling a fraction. So whenever I'm given a problem like this, I can start to set it up where I have hours over pay, or pay over hours. I can do it either way I want to there. It would probably make a little more sense actually to do pay over hours. It really won't change the problem as long as I write them correctly. So, and when I write the next one, I want to do the same thing, pay over hours, like this. So then I need to make sure that the two fractions have the same units on top and bottom. So now they told us she gets $247 for 13 hours of work. So 247 to 13 hours equals, at the same rate, how much would she make for 9 hours? So I don't know how much she would make yet. It's saying how much, but I do know the number of hours I'm asking about. So it'd be 9 hours. So now I have my proportion set up, and this is a P. I know that kind of looks like a backwards 9, but it's a P. Once we have a proportion set up, what we can do is we can cross multiply. So I can go like this, 247 times 9, 247 times 9, and they did give us a calculator on this one, so I'll come over there in just a minute, equals, and then we're going to cross multiply the other way here, like this. 13 times P is just 13P. So I do want to do my calculation here, 247 times 9. Oh, why isn't it typing it in? 247 times 9. All right. So that gives me a pretty decent number there, 2,223. And that's going to equal, I'm being all color-coded here, 13P. All right. So now what I want to do is, just like we've done on previous ones where we're solving equations, I want to know what just P equals. So I'm going to divide both sides by 13 so that it cancels out on this side. So I'm going to come to my calculator, I'm going to go divide by 13, and that equals 171. Equals P. So this tells me she's going to make $171 if she works for 9 hours. So I'm not working out the hourly pay on here. We set this up so that when I get to the end, I know how much she made for the 9 hours. You could have also done this a slightly different way. We could have said 247 divided by 13. And that would have gotten us 19. What that tells me, if I divide 247 by 13, that tells me she makes $19 an hour. If she makes $19 for every hour, and she works for 9 hours, I can say $19 times 9, and that will also bring me to the 171. So it's not always as easy to do it that way, but you can do it that way if you want, bringing it down basically to a unit price. So instead of looking at 13 hours, I can look at 1 hour of work. So she gets 19 hours for every 1 hour. If she works 9 hours, we just multiply by 9. So it's just two ways to do the same problem. Whoops. Help if I'm typing that in right. There we go. Okay, next. All right, so now we do have a proportion. Sorry, I'm just resetting my board here. So we have W over 8 equals 3 over 12. So once we have a proportion, a fraction equaling a fraction, we should be doing the cross multiplication. So W times 12 equals, and I'm going to only color code this first step, and then I'm going to move to a different, just like one solid color here. 8 times 3. So you can just see I'm circling from top to bottom, left to right, and then top to bottom on the other one. All right, so I'm going to go back to my orange for whatever reason. So W times 12 is just 12W equals 8 times 3, which is 24. All right, so now I want to solve this. I don't want to know what 12W is, just W. So I'm going to divide by 12 on both sides. Since I'm multiplying by 12, they cancel out. 12 divided by 12 becomes 1. I don't have to write 1W, just W. 24 divided by 12 is 2. If you're having trouble with some of your math facts, if that's not super quick for you, I would definitely suggest going on quick tables on here. That's a activity we already have loaded on here. We're just not assigning it this year, but it's still available for you to practice those math facts and get a little faster at that. All right, next. I'm just going to give myself a great big eraser here and just make that a little faster so I don't have to keep doing a new screen. There we go. That's better. Okay, so we're going to do this one again. I think I'm going to move away from the orange for whatever reason. 11 equals 4. All right, so I'm not going to go crazy with the color coding this time, just because that takes a little bit more time. So we have a fraction equaling a fraction, and we need to figure out what is y. It says round your answer to the nearest tenth. That tells me I'm probably going to end up with a decimal. Okay, so that's kind of a warning there. So we're going to cross multiply. And I'm going to just do this one without writing it down. You don't necessarily have to write down every single step. Once you get used to this idea, I know it's 7 times 4, and that's 28. Equals the other cross multiplication, which is 11 times y, so 11y. So that it just depends. If you like writing down each and every piece so that you know exactly what's going on, that's perfectly fine. But if you multiply that in your head and you write down 28, that's also okay by me. I know depending on the teacher, they may still want you to write down your steps. So just be, aware that some teachers may request that you still write down all of your steps, especially if they see that you're making mistakes. All right, so we want to divide by 11 here because I'm multiplying by 11. So we're going to divide both sides by 11. They gave us our calculator back here because we're going to have a decimal place, so we're going to divide by 11. And they said round to the nearest tenth. Well, here's a tenth, 2.5. 5 is my tenth. I need to make sure I look at the next decimal. As long as it's 4 or smaller, they all just drop away and it stays 2.5. If it was 5 or bigger, that's when we have to deal with rounding up to the next number. Everything still drops away on this side, but it just decides, do we leave it the 5 or do we round up to the 6? So it's 4 or smaller, we're going to leave it the 5. So it's going to be 2.5. Check. All right, and I didn't write it on the screen here, but it would be 2.5 equals y because these guys would cancel out. All right, next one. So now we're getting a little bit more complicated here because they're giving us a binomial. That's what this is. When we have two pieces, we call it a binomial instead of a monomial, which is one piece. So that's kind of some root words there. Mono means 1, bi means 2. If it's a trinomial, well, tri means 3, like tricycle, right? And you can even think of bicycle for binomial, 2 wheels, 2 numbers. So we're still going to cross multiply. It's still a fraction equaling a fraction. I'm going to go like this. The mistake I see made here is that we just multiply 5 and 10 because they're the closest. What this means is it's 10 times the entire top. So I need to put parentheses in. And then that's going to equal the other cross multiplication here, which is 4 times 3. So I just did that one in my head with 12. So now before I can start getting v by itself, I'm going to need to distribute this 10. So it's going to be 10 times v, which is 10v. 10 times negative 5, which is negative 50. That's going to equal 12 because nothing happened to the 12 on that side. All right, now I can start to solve. So this is going back. We're kind of at the point where we're at a two-step equation now, or we have 2 steps left. So I'm looking what's being added or subtracted to the variable. Well, 50 is being subtracted, so I'm going to add 50 to both sides. And then we have 10v drops down, 50 minus 50 cancels. That's going to equal 62. So now what's being multiplied or divided by the variable or to the variable? So we have 10. I'm going to divide because it's being multiplied. So I'm dividing by 10. 10 divided by 10 cancels, and we have v equals, it doesn't tell me to do any rounding here. But if I divide, and I'm going to check this right now, I would get 6.2. So it may very well accept 6.2. I'm going to try it out just to see what it does. If it doesn't, then we could just reduce this, right? Because they both divide by at least 2. So I could say 31 over 5, because 62 divided by 2 is 31. 10 divided by 2 is 5. And then they also have this mixed number piece here. So I'm assuming they want us to go even a step further and turn it into a mixed number. Well, how many 5s can I pull out of 31? Well, that would be 6, right? Because that would get me to 30. And then I would have 1/5 left over. So 3 answers that all mean the same thing. But it all depends on what they let us type in here. So let's see, will they let us type in 6.2? They did. So they let me put in the decimal there. Be careful, though, if you have a rounding issue, don't do any rounding on this one. So if you get a weird decimal that's not terminating, I would not use the decimal form. I would use the fraction form. So just be very, very careful about that if it doesn't tell you to round anything. All right. So we're going to go ahead and keep moving here. Negative 24 over x minus 5 equals negative 9 over x. So now they're just giving us a lot more negatives. And we have x twice in the equation. So they're throwing a few things at us. All right, so we're still going to cross multiply. That's the first thing we do. As soon as we see fraction equaling a fraction, we cross multiply. So negative 24 times x, well, that's just negative 24x, equals, and we have x minus 5 times negative 9. Remember, it's not just 5 times 9, or negative 9. It's this negative 9 is times the whole thing. And it wouldn't have mattered either if I wrote it this way. If I said x minus 5 times negative 9, I would put it in parentheses just so you know that you're not subtracting the 9. Just be a little careful about that notation. But you can put it on the end or you can put it on the beginning. Totally up to you, kind of preference-wise there. We do need to reduce this as far as, or not reduce, but simplify. So negative 9 times x, we get negative 9x. And negative 9 times negative 5, well, that's going to give me positive. 2 negatives make a positive. And 45. Okay, so now we're going back, quite a few sections there where we had variables on both sides of our equation, and we need to bring them together. I do tend to like to make them positive, but I'm not going to move this 24 simply because it's already by itself on the left side. So I'm going to go ahead and bring the 9 over to the negative 24. Just so that it gives me one less step to worry about. So I like to have those positives. If you watched those videos before, that was the comment I made. But it's not necessarily always the best method. So now we have negative 24 plus 9. They're opposites. We need to subtract. I have more negative because 24 is bigger, so it's going to be negative 15x equals 9 minus 9 cancels. And then we have 45 here because it comes down. All right, last step here, I'm multiplying by negative 15, so I'm going to divide by 15 on both sides. 15 divided by 15 cancels out, and I have x equals 45 divided by negative 15. Well, I know it's going to be negative because it's a positive divided by a negative. And then 45 divided by 15 is 3. Again, if you're having trouble with math facts, I'm going to point you back over toward the quick tables. That would definitely be something I would start playing with. And it's literally just multiplication practice. Addition, subtraction, multiplication, and division. We have one for each of them. And you can practice all of your math facts there. Very nice way to kind of increase those skills so that it makes some of these steps a little easier. All right, 2 more of these. Okay, so now we're going back to a word problem here, so we have to think about it. And let's read it, and we'll think about how to set this up. So Sheen runs 7 miles in 50 minutes. At the same rate, how many miles would he run in 75 minutes? So remember, this is one that we could actually do in 2 ways if we wanted to. So we could have it, and I'm trying to figure out how to put my microphone here a little nicer. So we could have it where we have miles over minutes for both of our ratios, because we're comparing. We're given 7 miles in 50 minutes. So 7 miles in 50 minutes. And we want to know when that's at the same rate, how many miles would he run in 75 minutes? So we don't know miles on this one, but we do know minutes for the second one, 75. So I've set up the proportion. You can also bring this down to a unit rate and figure out how long it takes him to run 1 mile, how many minutes. So we would reduce this down, so it would be 1 over a number, but you're going to end up with a decimal there. So that one's a little bit more difficult than the one we did kind of, I think, on number 1. But you could do it that way if you really wanted to, bring it down to a unit rate. So I'm going to go ahead and do my cross multiplication since I've got it set up this way. So I have 7 times 75, and they gave us our calculator back. So 7 times 75 equals, we get 525, and that's going to equal 50 times m, or just 50m. So now my goal is to get m by itself. I'm multiplying by 50, so I'm going to divide by 50 on both sides. So 525 is already in there, and I can hit divided by 50 equals, so it's going to be 10.5 equals 50 divided by 50 cancels, so m. So the number of minutes is going to be 10.5 minutes on this one. And they didn't say anything about rounding, so they are expecting a decimal, but they're not expecting you have to do any rounding. Oh, I'm sorry, it's 10.5 miles, not minutes. We had 75 minutes. Silly me. I said minutes a few seconds ago. All right. One more of these guys. Okay, so now we're looking at scale, and we use this method for scale quite a bit when we're trying to increase, the size of a picture, or even before they make a building, a lot of the time they'll have like a scale model of that building so they can kind of see all the aspects of it before they make, the great big building. We do this all the time in production. So this one, we're just going to be looking at the scale drawing of a painting, and it's telling us that the scale drawing is 1 centimeter to 6 inches. So for every 1 centimeter of this little small scale drawing, the actual painting is 6 inches. So we're bringing it down quite a bit smaller than its original size. Okay. So they ask us 2 questions here. The height of the real painting is 24 inches. So they're telling us this is the height of the real painting. What is the height of the painting in the scale drawing? So we need to go kind of back down. So we have scale. Let's see if we write this correctly. We want to do 1 to 6. That's our scale, 1 to 6. So 1 centimeter to 6 inches. And this is our scale. And that's going to equal our actual drawing. So we're using it to convert the measurement here. So for every 1 centimeter, we have 6 inches. Well, if I have 24 inches, I want to know how many centimeters I'm going to have there. So I'm going to go C for centimeters here. So we're going to cross multiply. 1 times 24 is 24 equals 6 times C is 6C. So I'm going to divide both sides by 6. And that'll tell me 24 divided by 6 is 4. 6 divided by 6 is 1, so C. So if it's 24 inches, it's going to be 4 centimeters. So I can type in 4 here, and it has the word centimeters for me. You could also do cm on some of the other, I was almost going to call these topics, on the other homework assignments. All right, so now we have in the scale drawing, the length of the painting is 7 centimeters. What is the length of the real painting? All right, so we still have a scale of 1 to 6. That has not changed. That's going to be our scale throughout this problem. And it might be different on your problem, but this is the scale throughout my problem here on the screen. So now, remember, this is model on top. Model, and this is actual. Or you could say the drawing. So it needs to be the same on this side. So now they're telling me the scale drawing is 7 centimeters. So now I know it's 7 on the top. But what I don't know is how many inches it's going to be. And I'll use a capital I there. I would never use a lowercase I because that could kind of look like a 1. So just be careful with that. So now you're going to cross multiply. I times 1 is just going to be I equals 6 times 7 is going to be 42. So the number of inches, if I have 7 centimeters, would be 42 inches. All right. So that was section 6, and I will see you in section 7.